Hi, welcome to CAP, Quantum Academy for Physics. This is our third lecture on units and dimensions. In this lecture, I am going to explain about dimensions and dimensional formula. What are dimensions? The power to which the fundamental quantities are to be raised. What are fundamental quantities? Here, the fundamental quantities we are taking mass, length and time. These are the three fundamental quantities. Here we are going to represent a physical quantity. So, okay, the fundamental quantities are to be raised. That is nothing but mass to the power 1 or 2 or 3, length to the power of 1 or 2 or 3, and time to the power of 1, 2, 3 or 0. It means the powers of mass, length and time to represent a physical quantity. Okay, and coming to the dimensional formula. What is dimensional formula? Dimensional formula of a derived quantity. It is for derived quantity and is the expression showing powers to the fundamental units to be raised. So it's an expression. Dimensional formula is an expression for derived quantity which shows the powers to the powers raised to the fundamental units. So these are nothing but derived quantities, derived physical quantities. Okay, dimensional formula is an expression, just like for example, expression of force is mass into acceleration. This is the expression for force. In the same way, expression for dimensional formula is mass, length into time, MLT, not into MLT, and also you can add to this amperes for measuring current, theta for measuring radian, okay, and so on. These are dimensional formulas. Okay, I will give examples. First example, velocity. How to write a dimensional formula for velocity? What is velocity actually? Velocity is displacement. Velocity is displacement per time. Displacement per time. Okay, displacement is measured in terms of length and time is measured in terms of second. Okay, this is a second is a unit. Okay, length is a physical quantity here. Okay, you here just write time itself, time. Okay, and what are the units for length and time? Units for length and time is we can measure this length in meters and time in second. Okay, now this also written in the form of meter per second. Okay, meter per second. Okay, if you if you use solidus, this can be written as m by s. Okay, this s if comes into numerator, here you have power 1. If it comes into numerator, this will this power 1 becomes minus 1. Okay, s power minus 1. Now how to write the dimensional formula for velocity? Okay, now the dimensional formula for velocity is, see, I am taking for mass, length and time. Okay, you have to write these formula in square brackets. This is a way of writing dimensional formulas. Okay, now mass, is there any mass? No, so m power 0, and length meters, right? So you have length m power 1, so L power 1, time t power minus 1. Okay, this is the dimensional formula for velocity. I will also give one more example, force. I will also give example for force also. Force F is equals to mass into acceleration. Mass into acceleration. And what are the units for force? Kg meter per second square. Okay, I am writing this as kg meter into s power minus 2. And dimensional formula for force is, what is the dimensional formula now? You have mass power 1, here you have power 1, so m power 1. So no need to write power 1. If you write m, if you write simply m, okay, you know that there will be a power 1. Okay, you can no need to write power 1. Now mass, kg is mass, meter is length, so L power 1. And second is time, t power minus 2. Okay, I will give a few more examples. I will explain dimensional formulas for few physical quantities. Okay, you just copy these by pausing the video. And these are the dimensional formulas for velocity and force. Here we are using mass, length and time. Mass, length and time are the fundamental physical quantities. Using these fundamental physical quantities, we are deriving the dimensional formulas for derived physical quantities. Okay, for derived physical quantities only. And next one, before explaining a few more dimensional formulas, I want to explain about principle of homogeneity. What is a principle of homogeneity? Principle of homogeneity. The physical quantities having the same dimensions may be either added or subtracted. Okay, the physical quantities having the same dimensions, may be either added or subtracted or equated. Okay, the physical quantities which are having same dimensions may be either added, subtracted or equated. So I explained about the dimensional formula. Then what about dimensions? For velocity, what is the expression for dimensional formula? What is the dimensional formula? We get m power 0 L t power minus 1. Okay, now the dimensions of velocity, the dimensions of velocity are the dimensions of 0, 0 in mass, this is mass, 0 in mass, 1 in length and -1 in time. Okay, -1 in time, -1 in time. So these are the dimensions. Okay, these are the dimensions for velocity and it's a dimensional formula. m0 L power 1 t power minus 1 is a dimensional formula and 0, 1, -1 are the dimensions for velocity. Okay, if principle of homogeneity, if the physical quantities having same dimensions, if the physical quantities having same dimensions, then those dimensions may be either added, subtracted or equated. I will give one example. How to add, subtract or equate. I will give one example. Take the example v equals to u plus at. This is equation for motion. This equation you will study in motion chapters, motion related chapters. Okay, what is the dimensional formula for velocity? m naught l t power minus 1. This is the final velocity and u is the initial velocity, so the formula will be the same, dimensional formula will be the same. And coming to the acceleration, what is the dimensional formula for acceleration? Acceleration is nothing but change of velocity by time t. Okay, and I will derive complete a into t here. Okay, into t. So what is velocity? Dimensional formula is m naught l t power minus 1 by time t into time t. Here I will write the capital T for easy calculation. Okay, t power minus 1, t power 0. Okay, t get cancels here simply. Then dimensional formula for acceleration is m naught l t power minus 1. So here m naught l t power minus 1. Dimensional formula for a into t is m naught l t power minus 1. Here you just look at this equation carefully. So on left hand side you have m naught l t power minus 1, and on right hand side also each physical quantity is also having the same dimensional formulas, that as velocity. Okay, so the physical quantities which are having same dimensions, may be added, that is u plus at. These may be added. Okay, u and at are having the same dimensions, so that this can be added or also subtracted. If the equation contains minus, you can also subtract them, and or also equated. Okay, v, u and at are having the same dimensional formulas. This can be added, subtracted or equated. Okay, this is about the principle of homogeneity. We will solve a problem on this in our next lecture. Here I want to explain a few more dimensional formulas for derived physical quantities. So v equals to u plus at. Here u is added to at. Why? Because u and at are having same dimensions. Okay, and u plus at is equated with velocity v. Why? Because u, at and v are having the same dimensions. Okay, the physical quantities which are having the same dimensions can be added or equated or also subtracted. Now I will explain about dimensional formulas for few derived physical quantities. And before going to explain the dimensional formula for some other physical quantities, I want to explain about supplementary units. Supplementary units. What are supplementary units? I didn't explain in our last classes. Okay. So besides seven fundamental units, seven fundamental physical quantities, we also have two more physical quantities. Those are plane angle and solid angle. These are physical quantities we have to measure. Okay, these are useful for measuring arc, angle. Okay, so plane angle, Unit of plane angle is radian. And unit of solid angle is steradian. And symbol for radian, symbol for representing the unit name is rad, R-A-D, and for steradian S-R. All these are small letters. Okay, so for plane angle unit name is radian, and for solid angle it's a steradian. Okay, and the symbol for the unit name, is for radian rad, and steradian SR. These are the two more units we have to learn. Okay, we will use these supplementary units also for solving dimensional formulas for derived physical quantities. Okay, first one, velocity. What is the dimensional formula for velocity? You know, the expression for velocity is displacement per time t, and it can be measured in terms of length by time t. Okay, now the dimensional formula is, there is no mass in this expression, so m power 0, and length, you have length power 1, and time t power minus 1. And coming to acceleration, what is the acceleration? Change of velocity by time t. Okay, now this is nothing but, you can write directly from here. What is velocity? m naught L t power minus 1 by time t. Now this becomes as m naught L t power minus 1. Here t power minus 1 is t power minus 2. You can add this. Now third one, force. Force is a mass. Expression for force is mass into acceleration. And mass is measured in terms of kg, and acceleration, here you have already the dimensional formula, m naught L t power minus 2. Okay, what is kg is a mass. Okay, this is m power 1 and m power 0, becomes m power 1 L t power minus 2. This is the dimensional formula for force. And fourth one, angle. Expression for angle is arc per radius. The unit for angle is radian. It's a dimensionless quantity. Okay, why dimensionless? Because here the dimensional formulas are can be written in mass, length, time, amperes, and so this we are using mass, length and time, but here there is absence of mass, length and time. Okay, this is the main reason. So angle is a dimensionless quantity. It's a dimensionless quantity. And coming to the fifth one, angular displacement. Angular displacement is arc per radius. This is also a dimensionless physical quantity. So the questions are like this. They will give a question as the physical quantities which are having units but no dimensions. Having units and no dimensions. Okay, and in the options they will give force, acceleration, angular displacement. If they give, what is the answer? Angular displacement. Why? Because it have units. Units are radian. Radian is a unit for angular displacement, and it have no dimension. It's a dimensionless physical quantity. And remaining dimensional formulas I will explain in our next lecture. Just please go through these fundamentals so that it will be helpful for deriving few more dimensional formulas for derived physical quantities. Okay, bye.